Hi everyone, welcome to SKM Academy. Today we are going to see Physics 12th Chapter 1 Example 1.11. So in this question they have given us an electric field is uniform and in the positive x direction for positive x and uniform with the same magnitude but in the negative x direction for negative x. It is given that electric field E is equal to 200 I cap Newton per coulomb for x greater than 0 and E is equal to minus 200 I cap Newton per coulomb for x lesser than 0. A right circular cylinder of length 20 cm and radius 5 cm has its center at the origin and its axis along the x-axis so that one face is at x is equal to plus 10 centimeter and the other is at the x is equal to minus 10 centimeter, which is shown in the figure 1.25. So in this question we are going to find what is the net outward flux through the each flat surface and what is the flux through the side of the cylinder, and then what is the net outward flux through the cylinder and what is the net charge inside the cylinder. So in this diagram they have given us when x is lesser than 0 the electric field is minus 200 I cap Newton per coulomb and for x greater than 0 the electric field is 200 I cap Newton per coulomb. So the total length of the cylinder is given as 20 centimeter and the value of x is along the left direction is minus 10 centimeter and value of x along the right hand side is x is equal to plus 10 centimeter. So first we are going to find out the flux at left face. So flux along the left face, which is phi of L is equal to E vector dot del S vector. So del S is the area vector and phi of L, which is equal to E, though it is a left face, the del S is written as minus del S cos theta, and phi of L, which is equal to minus 200 into minus pi into 5 into 10 to the power of minus 2 square into cos theta. So del S and electric field are in same direction. So the angle between the del S and the electric field will be 0 degree. So phi of L, which is equal to minus 200 into minus 3.14 into 25 into 10 to the power of minus 4 and cos 0 degree value is 1. And phi of L, which is equal to 200 into 3.14 into 25 into 1 by 10,000. So 0 zeros will get cancelled and the final value will be 2 into 3.14 into 0.25. So after calculating this value we will get phi of L is equal to 1.57 Newton meter square coulomb inverse. And similarly for the right side also we will get the same value. For right face, phi of R, which is equal to 1.57 Newton meter square coulomb inverse, because both the values for the left and the right direction, the right face are same. And the next we are going to find out what is the flux through the side of the cylinder. Flux through side of the cylinder. So here phi of S, which is equal to E vector dot L del S vector. So here the electric field and the area vector del S will be perpendicular. So angle between them will be 90 degree like this. So it will gives you the angle of 90 degree. So we know that the cos 90 value is 0 degree. 0. So phi of S is equal to E del S cos of 90. So cos 90 is 0. So flux through the side face of the cylinder will give you the value of 0. The next question is what is the net outward flux through the cylinder? So that we have to add the flux at left face, flux at right face, and also flux through the side of the cylinder. Net outward flux through the cylinder. So the net flux phi is equal to phi of L plus flux due to the right face plus flux due to the side face. So phi is equal to 1.57 plus 1.57 plus and side face value 0 Newton meter square coulomb inverse. So after adding the values, we will get the net flux phi is equal to 3.14 Newton meter square coulomb inverse. And the last question is, what is the net charge inside the cylinder? For this we have to use the Gauss law. Net charge inside the cylinder. So according to Gauss law, flux phi is equal to Q by epsilon naught. So we need to find out the net charge. So rearrange this formula for net charge. Q is equal to 5 into epsilon naught. So that we found out the net outward flux through the cylinder is 3.14 Newton meter square coulomb inverse. So substitute this value, 3.14 Newton meter square coulomb inverse, and the epsilon naught value is 8.854 into 10 to the power of minus 12 coulomb square Newton power minus 1 meter power minus 2. So after calculating, we will get Q is equal to 2.78 into 10 to the power of minus 11 coulomb. So the net flux value is phi is equal to 3.14 Newton meter square coulomb inverse, and the net charge inside the cylinder is Q is equal to 2.78 into 10 to the power of minus 11 coulomb. Thank you. We see you in next video.